This conference will now be recorded.
All right, good afternoon, everyone. Thank you for joining us for today's Eastern Carolina virtual chapter meeting. We're glad that you are here with us. I'm Katie Cox, PENC Membership Director, and I'm going to start out with just a few announcements of events and things that are going on at the state level. First of all, hopefully you all saw the officer slate for 2021-2022. It came out via email. If you have questions or comments or anything, you can contact Carl. He's in charge of that nomination for the officer slate. To voting, you don't have to do anything to vote. So if you're fine with the slate, do nothing and it will automatically be approved 30 days from when the email went out. And then upcoming events, we do have a webinar, a statewide webinar on April 28th. Information will be coming out soon, but it's on nature-based stormwater solutions. We have a Women in Engineering virtual event on May 11th, and that will be with Trish Hatley, who is the NSPE president. She'll be speaking. We are going to have a virtual Wilmington seminar. Usually our Wilmington seminar is in August. We are moving it up to June, and it will be virtual this year. The theme will be coastal resiliency. We're working on the speakers now, but information about that will be coming out soon. And then our PENC Summer Conference, we are moving that to August. It will give us a few more months to feel really good about having an in-person summer conference. So it will be August 29th through 31st in Wrightsville Beach. We are still working through some issues with the hotel contract. So no registration has opened yet, but I'm hoping that we can get all of that information out to you all next week once we have the contract signed. So August 29th through 31st for the summer conference. And I will have all of this information and these dates in the email that is sent out afterwards today with your PDH. If everyone could go ahead and mute their computers so we don't get any feedback while the presenter is speaking, that would be great. We will take questions at the end of the presentation today, but you can go ahead and type those into the chat box at any time. And Carl, I'll turn it over to you.
Thanks, Katie. Hey, everybody. Thanks for taking the time to join our Eastern North Carolina chapter meeting virtually. And want to tell you that you're in for a big treat today. We have Mr. Josh Lopez. He's with Terracon. He's in our Greensboro office. And Josh is a graduate. He's a Boilermaker, a graduate of Purdue. His title is geophysicist, which I think is pretty cool and probably carries some cred down at the bars when you're trying to talk to the ladies, you know, if you can tell them you're a geophysicist. Josh has a unique talent of being able to see in the ground. He can see through dirt. He knows what's underground, and he's going to show us a little bit behind the curtain of how he sees through the dirt. So thanks, everybody, for taking the time to join the meeting, and thanks, Josh, for presenting, and take it away.
Thanks, Carl, for that introduction. And you're right. Sometimes it's impressive to ladies, but a lot of times they just give me the laugh and say, huh, no, really, what do you do? Because it sounds like a fake job title. But as Carl said, I'm Josh Lopez. I am based out of our Greensboro, North Carolina office. My main responsibilities out here include some of this stuff like today, giving presentations, expanding the geophysical presence in the Southeast Division. And I'm happy to present to you guys this afternoon. So thank you for having me, and hopefully you guys will see something maybe you haven't seen before, and some of it just may be stuff you guys have seen or done on your projects already. So like Katie said, go ahead and if you have any questions, put them in the little chat. And if I see them in time, I'll try to get to them before I move on to the slide. And if not, I'll come back to them at the end of the presentation and can go back to any slides you guys may want to re-see or have a question about. So about me a little bit, I've been with Terracon here since September 2013. Been doing geophysics the whole time with Terracon. In addition to myself here in Greensboro, we have 2 additional field geophysicists who help me cover The Southeast Division for us, which usually means Southern Virginia, North Carolina, and South Carolina. However, in my time with Terracon, I've been able to travel across the country doing geophysical projects. I've been everywhere from California to Maine, from Texas to Minnesota. Seen a lot of different landscapes, done geophysics in a lot of different landscapes, seeing different problems and trying to solve different problems using geophysics. A lot of different methods under my belt that you guys may or may not have heard of. Ground penetrating radar, seismic refraction, downhole, electrical resistivity imaging, 4-pin electrical resistivity, electromagnetic induction, and magnetics are just some of them. But one of the great things about being out here in North Carolina is I consider kind of a gold mine for geophysics. We have such a vast change in terrain out here, and historically a lot of the towns in North Carolina have been around for a very long time. All different scenarios that go well for conducting geophysical explorations. So as Carl said, we're Terracon. This is kind of a map of where our offices are over in the North Carolina, Southeast area. If you don't know, we do environmental facilities, geotech materials consulting. The great thing about geophysics, while we're kind of housed in the geotechnical department, we actually get a chance to work with all of our departments and help everyone out and trying to solve some unique problems. So what is geophysics? The geophysics that we conduct here at Terracon and a lot of consultants do is called near surface geophysics, which means we're likely just dealing with less than 200 feet below the ground surface data. Nothing really deep, not plate tectonics, not looking for oil or anything of that nature, usually shallow stuff. We use surface methods that are minimally or non-intrusive to get our subsurface data. So unlike a drill rig where you're poking a big hole in the ground, we may just have a little hole that's like 4 inches deep into the ground to get our information. Today, I'm mainly going to focus on 4 methods that are generally used a lot in consulting, especially around North Carolina. The ground penetrating radar, seismic refraction, electrical resistivity, and electromagnetic induction. What I like to say is geophysics isn't meant to completely erase the traditional methods such as drilling or test pits, but rather complement and provide additional data for those methods. So jumping into ground penetrating radar and electromagnetic induction, this is a typical GPR setup you see in this picture here. It's usually an antenna with a controller, and you push it along the ground, whether it's in a cart or if you're on your hands and knees pushing it along the ground. GPR has some good pros. It's one, non-destructive, as you can see in this image. It just rolls along the ground. You're not, putting any holes in the ground, not tearing up concrete, none of that stuff. You're just getting all your subsurface data exactly where you go over, non-destructively. It's quick to scan large areas, such as like an airport tarmac. You can collect a lot of data in a short amount of time, which also helps help us keep the cost down of conducting our surveys. It's also relatively easy to mobilize these across the state. We have multiple of these units, and usually on a moment's notice, we can get out to sites if needed for emergency situations, just because usually it's just one person with that's operating this unit, and they can just drive it, in the bed of their truck and go on down the road. Some of the cons for GPR though and EM is it is limited in depth. Generally out here in North Carolina, we'll never get more than 10 feet of data. In the Piedmont out here in our tight clays, it's worse for ground penetrating radar. We can sometimes only get 5 feet. Downtown Greensboro, I'm lucky if I only see 4 feet. We go out to the coastal plains, out in Greenville area. You can see 10 feet all day long, and it's nice to be able to see that deep, get more data and see deeper objects. As I mentioned before, it's ground coupled, which can also produce another problem in a lot of the terrains we have here when it comes to wooded areas with heavy underbrush. You can try to push the cart through that terrain, but without some kind of clearing, which is more destructive, you're not going to get any kind of quality data to where, you know, it's not worth our time to waste your guys' money to even try to get data out there, just because the data is going to be useless. The antenna is going to be jumping up and down off the ground. The data is going to be pretty hard to read. So we just generally don't do those areas with GPR unless there's some kind of cleared path. And then lastly, this more comes into play when you're interpreting things in the field. The results can depend on the operator. Someone that's been doing it for 10 years is going to have more experience than someone that's been doing it for a couple years. They may encounter something specific on that site that's they never encountered before if they've only been doing it for a little while, and may not know what it is, interpret it wrong. But you know, that can happen with anyone, and you know, it's just some of those unique scenarios that don't always come up, but it is a possibility. That's why, if possible, we'll try to collect data, bring it back to the office, post-process it, and put a second set of eyes on it as well to help limit those errors. So this is maybe typically what people think of when they think of ground penetrating radar. They are looking for reinforcing steel and concrete, whether it be a slab, a wall, a column, CMU block walls. Reinforcing the pretty quick and easy thing to do with GPR. Figure out the spacing of it, figure out the depth of cover, figure out if it's even there. A lot of times, you know, at a lot of these old buildings don't have plans. As-built plans definitely may have not been made. You're gonna try to add additional loads onto a building, and you need to know what the reinforcing is like inside it. That's where GPR does great things. Can easily see that without having to chip away at a bunch of different spots, or coring or cutting into the concrete. Or if you do need a core and cut into the concrete, then GPR can help identify that in the field for you, mark it out in the field so that you won't hit that reinforcing. Pretty quick and easy surveys looking for reinforcing steel generally. Going a little deeper, we use GPR a lot for looking for buried debris out here or underground storage tanks. You don't want to be constructing on a site that looks like a vacant lot, and next thing you know, you're starting to dig into old foundations, a bunch of concrete rubble, you know, a bunch of brick, a bunch of even large wood pieces, timbers, or worst case, you find a underground storage tank that you thought that was removed, it's got gasoline in it and it's leaking, and then you got a bigger problem on your hands that's going to cause delays in your project, bring in cost more money that you didn't plan on. So GPR is great for identifying those two situations and either helping you plan for them at least, or let you know if you're not going to encounter them. Back to shallow again. GPR is good about finding voids under concrete. Generally, we like to take our void surveys a little further and figure out why there's a void. Most of the time, clients call us because they're seeing some settlement in the concrete slab. They're seeing cracking in the slab. Maybe there's water coming up through the slab, and their data just ask us, hey, we want to know if there's voids underneath the slab. Well, we want to also help them figure out why are there voids. A lot of the common causes we see could just be differential settlement where it's not going to move much more, but a lot of times it can be a broken utility, whether it be a water line that's leaking water all into the slab and making the soils a little saturated, or a sewer line that's got cracks in it, has holes in it, is wetting the soils above and causing them to go into the pipe and then washing away all those soils, which causes voids. And then we can delineate that area, figure out what is causing it, and help figure out what the fix should be, whether you're just going to inject grout underneath there, or if you may have to remove the soil or remove the slab and remove a bunch of soil. We can help you figure that out. Comes to concrete thickness, we can do a lot of spot checking for concrete thickness. You know, if you're putting in a lift to load cars up, you may have to have the concrete slab, 6 inches, and if you're moving into a new building, or if you constructed just a new slab and you're not confident that your contractor put in a 6-inch slab, we can check it relatively quickly in the areas we're going to be putting your anchors and verify, is it 6 inches, is it 4 inches, is it, what's it like? Or for more intense large sites, we can collect all the data on a grid pattern and provide an image like the one on the left, where we color code and contour the thickness and help you identify where you're going to have problems with thinner concrete. Maybe if you're running, if the clients or the on-site personnel are going to be running forklifts on there, and the forklifts are going to cause problems to the slab, you'll want to know where those potential issues could be in the future. Some interesting fun projects that we've got to do out here are a lot of marine GPR. This is one project I helped Carl with out there on this little pond on this property that they were going to acquire. They were wondering if there had ever been any, trash thrown in, vehicles abandoned inside it, what have you, before they purchased it. We use electromagnetic induction, EM, to scan over the pond on a little boat. We used a plastic john boat, and the EM is very susceptible to metal. And so we scanned over the pond, found these couple anomalies that were consistent with being large metal items. We then came back with GPR, scanned over them to try to get an idea if they were, what size they were, and in fact found a few, again, large metal anomalies. Probably cars. Unfortunately, the client didn't want to do any diving and get some eyes on exactly what it is, but at least we were able to provide where these items may be. This is a classic method of where we won't completely replace your intrusive methods. If this was underground, you still may need to get an excavator out there and figure out exactly what is there. We can tell you the where and about how much, but it's harder to tell exactly what it is until you put eyes on it. GPR can also help provide data in regards to the depth of the pond. If you're going to put a new deck or a pier out there and you need to drive some piles, but you're not sure the depth, you're not sure if there's a layer of muck out there that you need to drive through, we can help define those different layers instead of getting a barge out there and getting a drill rig out there and just drilling one hole. We can cover the whole pond most times in the time and cost that it would take to do the one hole with a drill rig. Some more interesting projects. Even though we can only see 10 feet, sometimes best case, that still could be helpful for some clients in knowing if they're going to encounter rock in that 10 feet. If you're going to be driving pile 8 feet down, if you're going to be just doing some excavation for a parking lot, and you'll want to know if you're going to encounter rock within that 2 to 5 foot range that you're only going to be excavating, then at least GPR can quickly tell you if you're going to encounter rock in your excavation or if you're good to go. That's the image on the right. It was from a parking lot that they were going to expand, and there was some outcrops. There was a small outcrop at the surface and some shallow rock just below it that they were going to have to encounter once they started excavating in this area. Some things they may see on TV more so is looking for unmarked graves. We do a lot of grave locates with our archaeological group out of Raleigh. A lot of times people be purchasing properties because they'll be building on it and there's a deed, or they hear stories that there's a cemetery on the site they're repurchasing, and they're going to want to know where that is, relocate the bodies, so it's not encountered during construction. We'll go out there with them, find the cemeteries, figure out there's still unmarked graves out there. Or in this case, in this picture, there's a corner of an existing cemetery that probably only had about 10 to 15 headstones out there. It's only like maybe 100 foot by 100 foot area, not very big. But in that area, we found about 200 unmarked graves that were down there, and helped find those for the cemetery owners to let them know that there actually still were graves out there in that area. Kind of EM and GPR together. You can use it to find other debris, like I said, USTs already, but landfill or buried debris. If you EM can a lot faster than GPR scan over areas. Both these are data sets from EM and find where the debris extends. You know, what half of the property is it on? Is it only in a certain pocket? Is it covering the whole site? It may not be able to, a lot of times at landfills, you know, they're built up from the surface and you can kind of quickly identify them just visually, but sometimes they're at grade and you can't tell where they had previously built buried stuff, and EM can quickly find out where that stuff has been buried, and then, like I said before, follow it up with test bits and figure out what's down there. Or drilling, if you need to drill for environmental reasons, make sure you're drilling outside of the landfill and not gonna poke right through the landfill itself. So starting to look deeper now, seismic refraction, electrical resistivity imaging are two of the main methods we use. We use a lot of seismic refraction out here in North Carolina, mostly. Some of the pros, again, it's non-destructive. This is an image of a seismic line where the geophones are those little red things, and they're just attached to a 4-inch pin that's just poked into the ground, so you're not going very far. Or electrical resistivity is just a 12-inch pin on that you poke into the ground, and again, straight line, not causing much damage to anything really. It allows you to get data from anywhere from 10 to 200 feet in depth. It doesn't give you very good shallow data, but that's where we're able to, you know, bring GPR back in if needed and get some better shallow data if that's when then additionally we're able to get, you know, continuous cross sections where you see this line that's set up on the picture where those geophones are. We're going to basically get a slice of the earth right underneath where those phones are, as opposed to, you know, just traditional drilling, poking a couple holes and trying to connect the dots. You get continuous profile of the subsurface. And then one of the good things about this test, not so much for us geophysicists, is that it's basically can be man-powered. So if you're trying to access a difficult slope, a wooded area, you don't want to completely clear it. A group of three field workers can go out there, carry the equipment on the slope or in the woods, get the array set up in a straight line without having to, you know, drive a truck or drive a rig back there, and get your data where you need it. Like I said, not fun for us field guys, but definitely still worth it once you see the data. Some of the cons with this though is generally seismic is always done with 2 people. Some seismic and ER, electrical resistivity imaging, may have 3 people on site to conduct the test. So with more people on site that has to do it, it can get more expensive to conduct the test. Additionally, you know, trying to get these jobs can be larger jobs, you know, 2, 3, 4 days, even a couple of week-long projects to where they can take longer to mobilize there just for the scheduling part of it. Trying to get a crew on site for that length of time can take longer to mobilize as opposed to trying to just get one person with GPR out there. Again, like I said, it doesn't replace traditional drilling. So while we get pretty good results without drilling, we still may need to drill a hole or two to confirm what we see. But for instance, on this line, once you drill a hole in the center, you are able to correlate the drilling results to our seismic results over that whole area. So you can replace, you know, 3 or 4 or 5 borings with just one line. So here's an example of some seismic data that we collected on a site where they encountered pinnacle rock during excavations in one area of the site, and we're moving on to the next area and wanted to know if they were going to encounter pinnacle rock there, because previously when they didn't know it was there, it cost them a lot more than what they had planned, and this time they wanted to be able to plan correctly with how much it was going to cost them in order to blast some of the stuff away. Pinnacle rock is classic thing we find out here in the foothills. A lot of vertical structures of rock that just stick up from the ground. I've been on sites where you could drill down 3 feet, hit some rock, move over 5 feet, and drill down 20, 30 feet and not encounter rock whatsoever. So when you're drilling, that can be very confusing if you don't have a full set of data like that seismic can provide you. And so seismic's good at finding that pinnacle rock where you're going to encounter it if you're going to encounter it, or if you're just looking for a general depth to rock over the site. You know, the red in this figure is outlining the hard rock material. So you know, there's a pretty consistent layer of hard rock down there, not even including the pinnacles. This is a set of shear wave data, which is pretty good about giving you a relative material strength. And it's also good inversions, which are pinnacles, where it, you know, you have that hard material over the soft material. What seismic refraction isn't great about, but can still give you an idea, is exactly what it is. So, you know, for instance, the green areas, without drilling, we don't know, you know, are those sand, is that sandy material, silty material, clay material? We just don't know. We know it's more likely soils of some sort. And then as you're getting into the yellows and oranges, you're definitely getting into more partially weathered rock. And then even the reds, we don't know exactly what type of rock it is, but we do know it is a hard rock that you're going to encounter. This is a second type of seismic refraction that's called P wave or compression wave. What this is good for, unlike the other set, it won't find those inversions, but if you're going to be just straight excavating and want to know when you're going to hit material that you're going to have to start blasting, Caterpillar has charts that they put out for their rippers, with the D8R being their smallest ripper. It correlates compression waves to their ripper strengths and lets you know at what compression wave velocity you're going to encounter material that is not rippable or marginally rippable. Again, doesn't tell you, you know, what kind of soils it is, what kind of hard rock it is. This one's not even as great as telling you partially weathered rock versus hard rock versus a hard sand. But it can at least tell you know when you're going to have to start planning the blast. Moving into more electrical resistivity, this is the better of what exactly is there and less how strong it is. Electrical resistivity is a property in all the soils that they have, and each soil has a different reading that it can give you. So this is better in delineating you know, your clays, your sandy material, your rock material. It's better about telling you what is exactly there and less about how hard it is. We use this a lot for karst investigation. So it's not used a ton in North Carolina, so to say, but more as you go north into Virginia and Pennsylvania. You start encountering a lot more of the karst topography out there. But if you're still looking for those softer areas, those clay materials, it helps. It can find those inversions as well over large areas and at deeper depths. But karst is definitely this is the bread and butter to find karst if you are thinking you're going to encounter a real sinkhole due to karst terrain. This is also really good for levees or dams. If you are thinking that there's water intrusion happening through the levee, you can, you know, scan the whole levee with this setup and then find the wet soils. A dry sand or a dry clay is going to have different resistivity values than a wet sand or a wet clay. So you're able to discern those with electrical resistivity as opposed to seismic. It would have to be softer instead of just being wet as well, which generally could be, but maybe not necessarily if it was more of a sand or gravel material. So we use this a lot for water intrusions on levee, which may be more applicable out here as opposed to karst. This was another project we did out for Carl in Carl's region. They were doing a horizontal directional drill boring on the site, And they started it and encountered a sedimentary rock, likely a mudstone. As they started to drill, they did some test pits, and to verify that's what they were hitting initially. And then they called us out there to say, okay, we don't know what this thickness is, where it's all located. What can you guys do? And electrical resistivity was one of those things we could do with this. The mudstone and the sandy plains have a resistivity contrast, as opposed to using seismic, where sands could still be hard, the mudstone could still be hard and would give less contrast. So we had them, lay out exactly where they're drilling at the surface, give us a straight line to go on. We went directly on their line where they wanted to go, and provided this 2D cross section of exactly where they're going, so they could know at what depths they were going to likely hit this mudstone, and if they were going to have to stay on top of it the whole time or go through it at some locations, depending on just what was more cost friendly for them. Again, this is another method where drilling helped verify. We had an idea of where the mudstone is, but exactly at what values needed to be more refined with drilling. And once we did, these 2 test holes along this line, we were able to correlate that pretty well over the entire 800-foot cross section. Again, some more buried materials if you're looking for deeper stuff. Electrical resistivity can pick up, if it's concrete versus native soils, if there's a bunch of timbers down there, a bunch of old piping. If you need that deep data and you even have dug test pits, and you dug your test pits down to 20 feet and you're still not finding the bottom of all that debris, then we can run electrical resistivity over it. And since it can definitely go deeper than 20 feet, we can have a better chance of finding the bottom of that debris or landfill area. All right, so kind of in conclusion, or for those that are rewatching and just skip to the end, we're here located in North Carolina. We have multiple people that can help do geophysical projects out here. Geophysics in general uses non-destructive methods to get your subsurface information. We like to complement it with traditional methods such as drilling or test pits. And then also it's a better way to get to less accessible areas, whether it's on a pond, in woods, on a steep slope. Guys and people in the field, people can walk a little easier on that than drill rigs can get up and down it safely. And then what can we find? In general, I like to say, if it's below the surface, we can find it. If it can be found, we can find it. There are some limitations with geophysics, and some stuff just can't be found with any kind of geophysical method you throw at it. There's nothing you can do but do a test pit to find it, or a hydrovac to find it. But if it can be found non-destructively, we have a great chance at finding it. Yes, are there any questions at this time?
If you have a question, please feel free to unmute and ask, or you can type it into the chat box.
Hey, Josh, I've got a question for you. I've seen you do this with the ground penetrating radar, and the screen just looks like a bunch of parabolas to me. How do you take that view on the screen and interpret it? Is that something just takes experience doing, or there's signatures that you're looking for?
It's
How do you
mostly experience.
make something out of it?
It's mostly experience, and so that's where experience comes into play. So for instance, if you think about stuff like finding a UST versus a utility is going to be pretty continuous. It's going to cross a whole site potentially, or go from one building to the other, where a UST, a tank, is only going to be 10, 20 feet wide, long at most. So what you're just doing is you're following that UST or utility. When you're scanning at the time, you don't know which it is, until you realize, okay, there's an endpoint, it stops, there's definitely a beginning and an endpoint. Okay, this is likely a UST or a drum or something similar to that, that's an object and not a utility necessarily. Similar for reinforcing steel, we can't generally get a size of the reinforcing steel. We can't generally tell if there's a difference between a pre-tension strand and a piece of rebar. But you can use some of those same signatures. You know, if the reinforcing is supposed to be spaced at 12 inches, and then all of a sudden you have this quote unquote reinforcing steel now that's coming in, you know, at 6 inches in this one location. Well, that one that's kind of the outlier is likely the post-tension strand and not reinforcing. Yeah, it can be a bunch of squigglies, and some of the squigglies, you know, are more consistent with, you know, if it's well defined, it's probably more of a man-made object. If it's less defined, it's probably, or sorry, I guess a man-made object like with a definite shape, like a utility or something like that. But if it's less defined, it might be, you know, more construction debris, like a broken up piece of concrete, something that has a less definite shape in it. It's still got a shape, but it's, you know, jaggedy and not a perfect circle or not a perfect square. Yeah, it definitely just comes with experience in interpreting that. That's why usually the only field interpretation we do and most companies do is utilities, USTs, and reinforcing. A lot of the other stuff like voids, debris, usually need to collect the data, stitch together, see what the site looks like as a whole, and can compare the site from one area to the other in order to better see exactly what's down there.
Josh, this is Caleb Wright. I had a question about your electrical resistivity survey.
Mm-hmm.
So we do cathodic protection design, and sometimes that means that we're looking to put in a ground bed where we would want to make sure there weren't any buried metallic structures nearby that would be interfering with. And also end up looking for things like resistivity through areas that we can't really get to, like for directional drills, to make sure that we're designing appropriately. So I'm curious, as far as your survey goes, are there convenient sizes that kind of make sense for you when you set up your array? Is it you know, easy up to a certain size, then it gets a lot more difficult, or does it matter?
You mean like in like the size of the area we're checking out?
Right. You know, I can imagine there'd be a lower end range and an upper range for your standard setup without having to jump through too many hoops.
Yeah, it's mainly dependent on us just, you know, talking with the client, figuring out, you know, what kind of I guess not quality, but detail do they want on their site. You know, minimum we can do 2 lines, and that's going to give you kind of an idea of what's going on the site. Or, you know, you can do a lot more. You can do 8, 10, 12, you know, do as much as you feel that would confidently give you enough information across the site. Generally, you know, when we do our proposals, I usually put in 2 options. Usually one of the what I feel like would be at minimum we should do, you know, this amount to give us any kind of idea. But if you know, would rather know everything, I'll, you know, give you a second cost for doing more information.
We would
So
mostly maybe a 600 by 600 square area, or 600-foot radius, sort of an area from a point, and we want to make sure we didn't have any buried metal pipelines or old railroad tracks or other things like that.
yeah, so if you're looking for more like debris like that, electrical resistivity would be the more expensive option. Electromagnetic induction, the EM, the one that gives you the more 2D plan view data, is actually the cheaper option, where you could probably get that 600-foot radius basically almost entirely covered in a day. As opposed to electrical resistivity, you may only be able to get 2 transects in a day and not give you that much data. But so it especially depends on what depth you're looking at too. EM, while we don't get any depth information from it, it does technically get data down to about between 12 and 16 feet, depending on what unit we use. So anything that's in that range will, basically have it go off and detect the metal in it. But then that's where we have to follow up with test fits or GPR to figure out what depth it is and exactly what it is.
Well, typically, we just end up going and doing a winter 4-pin setup to check resistivity up to 20 feet deep and trying to know what layer we'd want our anodes in for good resistivity or low resistivity to put current out well. And that's, I thought if you're doing the electrical resistance mapping anyway, that would also be very useful information as far as depth and design criteria. So the bonus would be being able to pick up the buried structures that might be a problem in the area.
Yeah, so the 4-pin winner is I didn't go over it just because it's I guess we could say it's less pretty. Yeah, that just gives you, like you said, your resistivity values at what depth you're looking at. It's kind of more like a boring in a sense, where you're just getting point data at depths. It can be used to find pipelines, because if you cross it, a pipeline, it's going to affect the data. It's just not as efficient as EM. And then also the 4-pin winner is a different setup as opposed to the ERI. Let me see if I can pull up a picture real quick of ERI, because ERI is basically it's basically anywhere from like 50 to 100 pins that are put in the ground at equal spacing and then connected with a big cable. And here we go. It looks more like this, so it's definitely more. It's why it's more expensive even than just your 4-pin winner. It's more labor intensive. It takes more time to actually physically collect the data. Where 4-pin winner, you basically set up your 4 electrodes, you press a button, get your resistance, and that's how you get your resistivity. You can imagine that way doing a bunch of times over this whole length of line. So you tell the machine to collect the values, and it's going to collect every pair of values basically it can get in order to build that 2D profile.
Wow, that's great. Very good. Well, occasionally we so good to know that there's tools like this available.
Yeah, definitely. EM is what you, if you're worried about pipes, old, houses, foundations, anything like that in a certain radius, EM is definitely the quick and fast way to figure out if there's anything out there. And I know a lot of times where we do 4-pin winner, it could be partially wooded, maybe out in a farm field or whatnot, to where EM is also the best suited for it based on the ground cover.
That's nice. Yeah, some of the projects we do are near kind of brownfield industrial sites. It's easy to think that you're going to go out and get a winter 4-pin analysis, in a short period of time, and it's going to be fine. But then if you don't know what's down there, that's potentially a problem. So it's good information. Thank you.
Yep.
Do you have any other questions?
Hey, this is Brad Blazer. I was curious, just how does your equipment map out location to correlate, to put together that map of what's going on under the surface?
So depending on what method we use, we basically have a sub-meter GPS, which actually it's really good even in open areas. In open areas, most time I'm getting within a foot accuracy. And then in wooded areas, I'm still getting that sub-meter, maybe more of a foot, 2 feet, or closer to 3 feet accuracy in heavily wooded areas, which is generally accurate enough for our clients. Not everyone has survey grade equipment, so they can go back out and precisely plot something to the centimeter. But we'll do one of 2 things for like a seismic or electrical resistivity. We can plot which is what we did here. We will collect coordinates along the whole length of the top of this line where we collected our data. And then what we can do is actually transfer that data, GPS data, and put it in like a CAD format, and overlay where our lines were exactly located in CAD. And then we use those GPS coordinates and assign, if you're gonna do depth to rock, assign a depth for those coordinates, and then use all that data to build a contour diagram of depth to rock over a site. When we do EM or GPR, both of those units can be connected to again a sub-meter accurate GPS. And basically, once we press go in a sense on our equipment and start collecting data, it's gonna collect the GPS coordinate with all of our data. So if if you have access to Google Earth, we can output those files into a KMZ format, and you can pull them up, on your laptop in Google Earth even, if you don't have CAD.
Thanks, very cool.
All right, any last questions?
I see one. I have not been hired by police to look for buried bodies yet. I'm waiting to see if we have one of those come up. Mostly it's cemeteries or churches that own the cemetery that have us look for stuff. But I'm rewatching the series Bones right now, and they use GPR a couple of times in a couple of those episodes, and it's pretty cool to see that, even though one of them's not accurate, but the other one was actually accurate.
All right, well, I don't see any other questions. Everyone that's on, if you are not a PENC member, please go ahead and type your email address into the chat box. That way we can get you your PDH form. The PDH form will be emailed out this afternoon, along with the NC Bell survey for you to fill out. Carl, any last words?
I'd just like to thank Josh for doing the presentation for us today, and thank everybody from the Eastern chapter and from chapters far beyond for attending our meeting today.
All right, thank you, everyone. We will see you next time.
Thank you, everyone.